Hi there, the Math Dog here. In this video, I'm going to go over an introduction to angles. So this is very basic stuff about naming angles, how to name an angle, and things like supplementary, complementary angles, linear pairs, vertical angles, and so forth. So this could be a video that could be relevant anywhere from, say, grade 6 on up to early high school. Anyway, let's get started. So topics here that I'm going to look at, I'm going to first look at degrees a little bit, then parts of an angle, naming angles, types of angles, adjacent angles, supplementary angles, linear pairs, complementary angles, and finally vertical angles. So degrees. 360 degrees is considered one revolution. I'm going counterclockwise. That clock goes this way, I'm going the other way. So 360 degrees is one revolution. So this is a quarter revolution right there, and that's going to be 90 degrees. Continuing, a half revolution is 180 degrees. You can see on the protractor here that's 180. Then 3/4 of a revolution is 270 degrees. So I've come 3/4 of a turn or revolution. You could also consider a revolution a turn. And finally we end up back where we started at, which is 360 or 0. You could actually continue on another full revolution. 2 turns would be 720 degrees, etc. And we're only talking about positive angle measures right now. But counterclockwise is considered positive, and clockwise on angle measures is considered negative. You could actually talk about, for example here, this would be a negative 90 degree angle. This would be a negative 180 degree angle, negative 270 degree angle, and negative 360. So you can talk about which direction you're going with angles. So the 360 probably comes from the fact that many moons ago, people noticed that the Earth made one complete cycle in roughly 360 days. Well, actually now we know it's like 365, and then there's a little fraction a day. That's why we have to have leap years so the calendar stays on track. But the 360 is related to one cycle of the Earth from many moons ago. Okay, so parts of an angle. We have the vertex, which is a point from which 2 rays come out of. So these 2 rays intersect at the vertex. These are also called arms. So a ray has the characteristic of an endpoint, and it goes forever in one direction. So here's a ray, here's a second ray, here's the vertex. Okay? So an angle consists of 2 rays and a vertex, or 2 arms and a vertex. Okay, naming angles. So in this first example here, I have this one angle here. So one way to name it is using 3 letters, 2 points on the ray, and then the vertex. The vertex must go in the center. So one way, and I'm going to use this to represent angle. Textbooks usually do it like this, but my angle measures look like L's, so I do this to distinguish it. So one way is angle C, XA. You could also name it though AXC. So we're using 3 points. One is the vertex. The middle letter has to be the vertex. Another way, in this case, there's only one angle here. I could actually just call this angle X. That's not always going to work, but in this case we can do that. And then I called this also angle 1. So there's 4 ways to name that angle. Now, in this next example, we can't do that because we can't use the method in 3, because if I say angle T, there's actually 3 angles that have angle T in them, or have a T in them. You've got angle MTW, which is right here. Well, that's also congruent to, and this means congruent. Congruent is like same, it means same shape and size. So angle MTW is the same as angle WTM. You could also call this is the same as angle 1. So that's angle 1's another way to name that angle, which is angle MTW, angle WTM. Okay. You also have then angle KTW, which is congruent to angle WTK, which is congruent to angle 2. Okay, so the reason I can't use angle T here because I don't know which angle I'm talking about. I have to be more specific. Then there's the large angle. You've got angle MTK, which is congruent. That should be a K. Let's fix that. So angle MTK is congruent to angle KTM. And I didn't call it this, but you could call that, say, angle 3. So you have 3 angles here that have T as a vertex. So that is why we can't just say angle T here, because we don't know which one we're talking about. Okay, types of angles. So first you have an acute angle. So this is an inequality sign. It means less than. So it points to the smaller number, opens to the larger number. So an acute angle, by definition, is greater than 0 degrees. I'm going to call the angle that I'm talking about X, and it has to be less than 90 degrees. So that encompasses that's 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, 90 degrees. So it's up to 90. So the angles we're talking about are in this area right here. Does not include 0, and it actually does not include 90. So it's all these angles in here. So my vertex is right here. It's hard, can't draw that, can't get it on there. Vertex is right here, and it's going to be a ray, these rays in this area here. Okay, so that's an acute angle, greater than 0 but less than 90. Then we have the right angle, which is exactly 90 degrees. Which is right there. Notice the right angle forms an L. So in a diagram, a right angle is represented by a square at the corner of the angle there. So angle ABC is a right angle, which also would be angle CBA is a right angle. Also angle B is a right angle there as well. So right angle equals 90 degrees exactly. Okay, then we have obtuse angles. So obtuse angles are greater than 90. And I'm going to call X my number here. And it's going to be my angle measure. X will be my angle measure. It's got to be less than 180 degrees. So now we're talking about angles starting just after 90, and we're going to go this way. These are all obtuse angles right here, up to 180 but not including it. So it's this section right here. So all the angles that sweep through this area right here are obtuse. We're assuming, again, notice, assuming we're starting one of our rays is right here. Let's use it. Let's not use a highlighter there. Our ray is right here. So here's one of the rays. That's the starting ray, so to speak. And then this is the ending ray here, and this would be an obtuse angle. Anything in this shaded area here, anything that sweeps through this shaded area is an obtuse angle. Then we have straight angles. A straight angle is simply a straight line. So straight angle is a half turn, as we talked about earlier. So straight angle equals 180 degrees. Okay. Oops. So straight angle is simply, again, a straight line that has a measure of 180 degrees. Say this is A, B, C. So measure, M standing for measure of angle ABC, is 180 degrees, which also could be angle CBA. Okay. And finally, we have a thing called a reflex angle. And a reflex angle, so, is going to be anything starting at 180. So it's greater than 180 degrees, and it's going to be less than 360. So those angles sweep through this following area. So starting here all the way to 360 in here. So it's this area swept out right here. So any angle that sweeps through here is called a reflex angle, from 180 to 360. So actually we're talking about, though, the measure, let's draw this over to the side. So I'm talking about starting here. This is 0. Oops. This is 0. There's 90, there's 180, so I'm talking about anything greater than 180 to 360. So I'm talking about angles that would sweep out like this, between 180 and 360, and 360 takes you right back where you started from at 0. So these all would be reflex angles here. So you're sweeping out, notice you're actually sweeping out to like right there. That's how far you're turning on these angles. Okay. I don't think I can draw this. I can't draw this on that little protract. Doesn't work. I guess I could do it outside of it like this. So like that particular angle here is roughly probably 282 degrees. So we're sweeping out counterclockwise 280 some degrees there. Okay, next we're going to talk about adjacent angles. So 3 properties of adjacent angles that we need to be aware of. So adjacent, in layman's terms, normal terms, means next to. So like your next door neighbor's house is adjacent to yours. So adjacent angles are 2 angles that one share a common vertex. So they have a common vertex, in this case in my diagram, M. They share a common side or arm or ray. Okay, this angle here, I'm going to also call this 1 and 2. So they share a common ray here, MT. Okay, So these two angles share, in this case our vertex is M. So the ray is MT. So I'm going to make a note here. It's ray MT, not TM. For other things it doesn't make a difference. For lines and line segments it doesn't make a difference, but ray TM would start at T, go through M, and it would actually go that way, which is not the way I want it to go. So ray is like a flashlight. You got, here's your flashlight, the light comes out of it. That's like your vertex, and the light goes out that way. So MT is a distinct ray. It's different than TM. Okay, so we need to have a common ray, common side, and these angles cannot overlap each other. Notice that angle BMT here and XMT do not overlap. They share a common ray, but they do not overlap. If they overlap, they are not adjacent. So here's an example of two angles that are not adjacent. Angle TAB and angle VXB, because they don't share a common vertex. Okay, and then in this case, angle VHQ and NHQ are adjacent. We call those angles 1 and 2. Okay, VHQ though and VHN are not adjacent. So notice the interior area of these two angles. In this case here, I'm looking right now at this. Okay, so these are not adjacent. Because here's the area inside VHQ, the interior area. Okay, doing that in red. Okay, NHQ I'm going to do in yellow, or VH. So here's VHQ. VHN is here. Notice how the yellow and the red overlap there. So those are overlapping angles, so they're not adjacent. And the same would be true NHQ right here. Let's do that in blue. So NHQ's, the interior of NHQ is here. Here's NHQ, which is also QHN. And VHN, which is in yellow, they're not adjacent, and there's an overlap of the yellow and the blue there. So adjacent angles cannot overlap. They share a common vertex and they share a common side or ray or arm. Okay, supplementary angles. Two angles are supplementary if the sum of their measures adds up to 180 degrees. As I mentioned earlier, this little m means the measure of angle 1. So I have angle 1 here has a measure of 115 degrees. Angle 2 has a measure of 65 degrees. When you add those up, it gives you 180. So we say angles 1 and 2 are supplementary. So now linear pairs. Two angles that are supplementary, that is, add up to a measure of 180 degrees and are adjacent, are called a linear pair. So here's an example of a linear pair. Angle QTS and angle CTS, call them also angle 1 and 2. These are supplementary because the sum of their measures forms a straight angle. Notice that's 180 degrees there. And they're adjacent because they share a common side, TS, ray TS. Okay, so in this case, the measure of angle QTS plus the measure angle CTS equals the measure of angle QTC, which is a straight angle, equals 180 degrees. So a linear pair, not all supplementary angles are linear pairs, because you could have, like here, you could have this angle here, say it's 140 degrees. Then you have an angle here that is 40 degrees. They're not adjacent, but they are supplementary because the sum of their measures add up to 180. So a linear pair is a special type of supplementary angle where the two angles are adjacent to each other. So then complementary angles, two angles that are complementary if the sum of their measures is 90 degrees. So again, nothing about being adjacent to each other. But notice this angle is 55 degrees, this angle is 35 degrees. The sum of their measures will add up to, in this particular example, 55 degrees plus 35 degrees equals 90 degrees. So in fact, they are complementary. Okay, vertical angles. So angles that point at each other are vertical angles. So angle AXD and angle BXC are complementary. Well, so is, are vertical angles. And then angles AXB and angle DXC, those are also a pair of vertical angles. So there's two pairs of vertical angles here in this diagram. If you want, you call this angle 1, 2, 3, 4. So angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. Okay? Vertical angles are formed by intersecting lines or line segments. Okay? So again, angle AXB and angle DXC are vertical angles. They point at each other. Angle AXD and angle BXC are vertical angles because they point at each other. Okay, there's more though to vertical angles than just defining them. There's a very important property. So we're going to demonstrate here that the measure of angle 1 equals the measure of angle 3. Those are vertical angles because they point at each other. So our conclusion is going to be all vertical angles are equal. This will always be true. And here's why. Okay, so angles 1 and 2 form a linear pair. So therefore the measure of angle 1 plus the measure of angle 2 equals 180 degrees because they form a straight angle like that, and they have to, therefore that has to be 180 degrees. Notice that's also true, so that's 180 degrees. Notice that's also true though for angles 2 and 3. Okay, we know the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay, now two things that are equal to the same thing are equal to each other. This is equal to 180, this is equal to 180, therefore this, and this have to equal each other. So I can write the measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Now, a little bit about equation solving. So it's a teeter-totter. So if I have a teeter-totter balanced, but then if I add something over here, it's going to cause a teeter-totter to go like this. So in an equation, I want to keep it balanced. So if I add that little weight here, I have to add it to the other side as well to keep it balanced. Just like if I have, this is my original condition, I take this away, I have to take this away, and that's what I'm going to do here. I'm going to take away the measure of angle 2 from both sides of the equation. So when you solve an equation, there's an equal sign there, that's why it's called an equation. When I'm going to subtract the measure of angle 2 from both sides. Well, anything minus itself is 0, so I'm left with the measure angle 1 equals the measure angle 3, which was what I was trying to prove. So this is a proof because here's angle 1, angle 3 have the same measure, and they are vertical angles. So all vertical angles will always be equal. So this concludes the video. If you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.